Okay, a company wishes to introduce a video on demand system to the public over the internet. Producer can produce a video and submit it to the company for acceptance. Once a video is received by the company for acceptance, the company appoints a panel of reviewers to review and accept the video for the video library. When a video is accepted, it will be added to the video library and inform the producer. If not, video will be rejected and informed to the producer with the reason for rejection. Viewer can go through the list of videos available in the video library and subscribe. Subscribers can watch the videos at any time. Okay. At the end of each month, the company calculates the monthly payment for each subscriber and produces an invoice. These invoices should be sent to all subscribers by a delivery man employed by the company. Okay. Now they are asking you for the entities or the external entities and the internal entities of the scenario. So if you see here, I will draw squares around these entities or the circles around these entities, whatever is available. Oh, let's say a circle. Video on demand system to the public over the internet. Producer can produce a video. So a producer is an external entity. Producer is an external entity. Can produce a video and submit it to the company for acceptance. Once a video is received by the company for acceptance, the company appoints a panel of reviewers. So reviewers, they are also external entities to review and accept the video for the video library. When a video is accepted, it will be added to the video library and inform the producer. If not, video will be rejected and inform the producer with the reason for rejection. Viewers can go through the list. So viewers are another set of external entities. Okay, go through the list of videos available in the video library and subscribe. Subscribers, so they are the other set of entities. Subscribers can watch the video at any time. Okay. And there's another person. At the end of each month, company calculates the payment for the subscriber and produces an invoice. These invoices should be sent to all subscribers by a delivery man. So he is also an external entity. So out of these five, 1, 2, 3, 4, 5, you can write any 4 here. All right. Out of these 5 people, you can write any 4 of these external entities here. Is that clear, everyone?
Yes, sir.
Yes, sir.
Now, whenever you are doing the exam, okay, whenever you are doing the exam, take a pencil and circle the entities. If you are dealing with a DFT question, circle the entities. When you are reading the scenario itself, circle the entities. And you can draw a box around processor. Okay, fine. Draw a context diagram to represent the above scenario. What is my system? Video on demand system. So that is going to come in the middle, right? So I will draw a square in the middle. This is the system. This represents the system. So I'm going to say video on demand system. Yeah. Say a video on demand system. Did you get an update for Zoom? I got it today.
What specials in the update?
There are a few applications that you can download and use in Zoom. It's in support meeting. Applications. There are a lot of applications. I don't know, but there maybe a chat application was there. I saw whiteboard application. A lot of things are there. You have to check out one by one. Video on demand system. Now this is my system. In a context level diagram, we just write the name of this, and we can write the external entities that we identified around this. So we have the producer, reviewer, subscriber, viewer, and delivery man. Producer, reviewer, subscriber, viewer. Reviewer, viewer. So let's say producer, reviewer. Then we have the viewer, subscriber, and the delivery. And you're going to draw circles around all of these people. So producer, subscriber, so we will see what they have to do with the system. You can see this video. A producer can produce a video and submit to the company for acceptance. So I can say this producer is going to submit video for acceptance. Okay, submit video for acceptance. So this will actually have an arrow here. On this side. This arrow is important. You have to draw the arrow which direction it is flowing, data flowing. Okay. Then once the video is received by the company for acceptance, the company appoints a panel of reviewers to review the and accept the video. So reviewers review and accept video. Review and accept video. Then when the video is accepted, it will be added to the library and inform the producer. Okay. So producer has to do some more with the system. The system will inform the producer about the acceptance. Okay. That is going to go this way. That way, so what is happening there? Inform about acceptance. That is also going to happen with the producer. Okay. Viewers can go through the list of videos available in the video library and subscribe. So go through the list. That is one thing they can do. And the other thing that they can do is subscribe. The two things they are doing. So like this. Okay. So those are the things the viewers are going to do with the system. Fine. Then subscribers can watch the video at any time. So they can just watch video. I can just say watch video. So they are actually taking something from the system and watching. So we go the other way around. Okay. Arrow will be pointing this way. Right. And the last one, invoices should be sent to our software delivery man employed by the company. So he is taking something from the one and sending, so it's also coming out. I would say he's deliver invoices. Deliver invoices. That is the job of this person. So he's taking the invoices from the system and delivering it to. So it's coming from the system to this place. The arrow should be pointing this way. So that is going to be your context level diagram. Okay. This is how your context level diagram should look like. Clear, everyone?
Yes, sir. Clear.
All right.
Yes, sir.
So,
Yeah.
yes, sir. I said yes, sir.
So we will go down to this. List the processors in the scenario. There are 1, 2, 3, 4, 5, 6, 7. 7 processors they are asking for. What are the data storage required? So we will go for that later. So we will try to find the processors with a square maybe. Produce a video. That is one process. Okay, produce a video is a process. Process is something that we are going to do. Submit to the company. That's the process. Appoint a panel of reviewers. Appoint a panel of reviewers. Review and accept video. Add to the video library. Subscribe. Calculate the monthly payment. Produce invoice. Send invoices to customers. To subscribe. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We can write one of them. Any 7 of them. Okay. So those will be the processors. Now the data storage required. Now we have to store the data. We have to see what data storage is required here. So I will just use the highlighting option to say what storage we need. Add it to the video library. Video library is a storage. Say you should have a storage of a set of subscribers, and you should also have a set of producers. Monthly payment for subscribers. Monthly payment for subscribers should be recorded. That's about it, right? So these 4 will be your data storage that you need to store. Data that you need to store would be this. Okay, so we can also have what else? List of videos available. That is in the video library, right? Video library we do have. So video library we have. That's it. So these 4 would be your data storage. All right.
Okay, sir.
Then we have the last one, level 1 DFT for the scenario. Now we have to draw the level 1 DFT. So inside this, you're going to have the process boxes as well. Okay, so the external entities would be the same. External entities would be the same, and these data flows also would be the same. Okay, data flows also should be the same. And inside this, you will have to draw some processes. You will have to have some reviewers or let's say the data stores. These 4 data stores should be there. And there should be a receptionist to accept and accept the video and store it in the video library. All right. Those things are required there. Okay, I'm not going to draw the whole thing. So whatever that should be inside the processors, you have to draw here. Okay, all the rest will be the same. Okay. Multi-processing, online processing, real-time processing. Internet of Things, of course, we did not do yet. Unit 13 or unit 12. When we do that, we can do this question. Oh, nice. We will try to do the CSS part. Right? I will send you this question. Send it to me by 11 o'clock. Can do?
Okay.
So this is a CSS type question, so you should be familiar with that now. It's a very short question. Try to finish it as quickly as possible and send it. Okay?
Okay, sir.
Sir, what to do, sir?
I have sent the question to the
Yeah.
group. You have to do the question and send it to me. Send the answer to me.
Sir, we must be in the meeting, no?
There is a web page. Okay, I got Nabil's answer. Thank you. The web page has to be developed to enable individual students of a school to submit their personal details online to the server maintained at the school. The information required to capture are given in the first column in the following table. Fill the second column with the most appropriate input control required to capture those information. Complete the third column by providing a justification for each such for selecting such control. So here we have name with initials. So it can be anything, right? Name with initials can be anything. So I would use a text box to capture the details. So the first one we can use a text box. Justification. Why are we using a text box? Gender. We can use a radio button. There can be only one choice, so we are going to use a radio button. Name of the class teacher to be selected from a list. So the child can have only one class teacher, so I can use a combo box. A list where only one item can be selected because only one class feature can be there, right? So they're using a combo box here. Sports, cricket, football, netball, swimming, chess. So here we can choose more than one item. So I can use a checkbox. More than one item can be selected. All right. Are you guys clear on that? Yeah.
So if class teacher can't be used, drop down.
Drop down is combo box.
Okay.
So I will say okay. Drop down. Both are the same thing, okay?
Oh, okay.
So these are the things that will be coming for the part A. Part B. More thing. Consider the following CSS rules. P color red, blue color dot blue. Dot blue means it's a class. Right? Then green, color green, dot pink, P. Dot pink in class P. Paragraph should be in pink. Okay. HTML code segment is here. And the color reason. Right? It was just P. It was just P. The color should be red. Color should be red. Reason, I will tell the reason later. P class blue. P in class blue. So dot blue. Color is blue. So it should be class blue. The color should be blue. In P class blue, ID is green. That paragraph is going to be green. These are straightforward stuff, right? If class pink, now there's a class called pink. In that class, I'm going to draw a paragraph, and that is going to be pink. All four colors are used here. So you can say the reasons. Ordinary paragraph. Or you can say it does not belong to any class. Paragraph in class blue. And paragraph with ID green. Here you can say paragraph that belongs to class pink. So these will be the reasons. Okay? Simple. So this CSS question was kind of very easy. So we are going into the database part. Where we need to do this method of this EDF. Okay. I will not give you that much time for this. Now it's 11:16. By 11:30, you have to finish this, and I will start at 11:30 exactly. So you finish it or not? I start at 11:30. So finish it as quickly as possible and send it to me. 11:30, we are going to start. Okay. I have sent it to the group. Nabil. Oh. Should I send it to I can't send the picture. To the Zoom chat, I am unable to send a picture. Third, you don't have access to your says a database has to be created in a school to store the following information. We have a registration number, name, gender, class, name of the class teacher, uh, and sports. Fine. So what are the main problems that might occur when the above data is entered in a single table of the relational database? What problems can occur? One is data duplication. And because of data duplication, we will have inconsistencies of data. So these two problems can be there. Okay. Then propose a method that you can use to design a database to overcome problems stated above. So this is a straightforward question. Normalization. So normalization is the only process that we can use to make sure all the data are, all these problems are not occurring. So we have 3 levels of normalization. So we can talk about it later. Then obtain relevant relation using the method that you have proposed in B. So relevant relations means relevant tables. Okay, and we are going to break this table using normalization. Fine. So what are the tables that we can create? In the first normalization, what are we going to remove? We are going to remove the repeating groups. The repeating groups, what are the repeating groups that we have here?
Class.
Class. So we're going to remove that class from here. And where are we going to store it? So we have repeating groups not in class actually. Repeating groups are there in this sports. Cricket and swimming done by this. Basketball and chess done by A41. So we have to separate the sports table first. Okay. So in a sports table, we will have sports ID, which is going to be a primary key. ID. And sport. That is going to be my first relation. Okay, now the sports column is taken. That is first normalization. Repeating groups are removed. Second normalization, what are we removing? Partial dependencies. So partial dependencies, which is going to partially depend on the primary key. Right? Something which is going to partially depend on the primary key. You can see a class. The name of the class teacher, class. Okay. A1, A2, A3, A41, A42. Common key. So this one depends on the primary key. Gender depends on the primary key. Class depends on the primary key. Sumana D depends on the, does not depend on the primary key. So I have to remove the name of the class teacher and the class. This class teacher. Right? So I can take a relation as class. And I can say the class as the primary key here. And class teacher as the normal attribute here. Okay. So we have removed the transitive primary key as well. So class and class teacher will go out from here, but they have to have a relationship. So class should be there in the registration table as well. So in the registration table, you will have, or you can have a student table, registration number, name, gender, class. Okay. So you can have a student table where I can have the registration number as the primary key. Then we have name, gender, and class. Name, gender, class. Okay. So this is the set of tables that I'm going to have. I'm doing this because class and class here are going to be a primary key and foreign key into tables. Okay, here it is going to be a foreign class. Here it's going to be a primary. So these are the tables that we are going to use after normalization, right? Then give DDL statement needed to create the table from the given relation in the above. Oh, so to do this, what we can have? So all are Vacha, as far as I know, Vacha. So I can say for the first one, create table ports. You can say ports ID and Vacha five. You can say not null constraint is given to them. And ports port is a Vacha again. I can give about 20 for that. And before we finish, you can say primary key is ports ID. And don't forget to send port. So that is how you create the sports table. Then we have the class table. Create table class. In that, I'm going to have class attribute, which is the voucher again, maybe 5 optional constraint is given, and class teacher voucher, teacher's name can be 25 present, primary key going to be so that is how you create the second one. The third one is table student and here we have registration number, yeah, yeah, 6 characters, null, and name and yes, gender, characters, next line. After that, we can say class but 5 characters. Primary key is registration number. Foreign key is class first. To class dot class. It means class in the class table. Okay, refers to class in the class table. So we are defining the foreign key as well as the primary key here. Okay. See the definition of foreign key is okay.
Excuse me, sir.
Yeah.
The screen is. I can't see the screen, sir.
Screen you can't see.
It says ICT with Birchman started screen sharing. That's it.
Bandwidth problem.
We can see, sir.
Can see, right?
Sir, it talks that that's it, no, sir. The D part or everything finished, no?
Yeah. Should be a small yes. Foreign key is the class and references class in the class table. This is how you define the SQL table.
So now we use Avacha Cha fine, no, sir. Now for unlimited characters, just leave it null.
Yeah. If you don't know the number of characters, you can leave it.
Okay.
Okay.
Yeah, sir. Done.
Yes, sir.
Show the A, B, and C will look like this. Done. Okay. we are going to the essay part. Which time question?
Sir, a little show the table, will you?
Which one? Of course, you should have done this too.
Sir, not this, this one, the
Database
code
what?
segment.
Which one?
Okay, sir, okay, done. So this is IP address.
Okay, can you try the Python question?
The homework.
Oh, it's 12.
11:55.
Can you do this question and send it to me by tomorrow?
Okay, sir.
Okay, so we have 1, 2, 3, 4 here. Got it. So next class, we will decide on a date. Before Friday, we have to finish another 3 hours. Which then we can.
The next class when, sir?